Okay, good day. Today we are solving password problem from May 2016. So this is an example of eccentric welded connection. So the problem states that a bracket is welded to a steel column as shown, given A is equal to 200 mm, B is equal to 500 mm, load P is equal to 360 kilonewton, allowable weld shear stress is 93 MPa. Okay, so first calculate the load, the weld in Newton mm when A equals 0. So when A though is equal to A is equal to 0, so it's not eccentric. So the load P is here. Okay. So when there's a hint here in Newton mm, so basically it's talking about stress. No? Stress. Say stress Y. Stress Y is equals to force over area. So the force here is equals to 360 kilonewton. So the area is the area of the weld. No, area is equals to the area of the weld, which is this. Okay. Now there's is two sides of the area of the weld, which has a length of 500 mm. Let me write that again. Okay. So when we say welded area, this is always considered as 1 mm strip. No? Strip. Just like we are solving um, dams just like dams, we use in dams is 1 meter strip. Here in welds is 1 mm strip. No? So the area is 500 mm times 1 mm times 2, because there are two sides of welds here and here. So we have 1000 mm squared. Okay, so for stress Y is equals to 360. We make it in Newton, so times 10 to the power 3. This is Newton, and then 1000 mm squared. Okay, Y is equals to 360 Newton mm squared. Newton mm squared. Okay, 1 mm strip. No? Pero we can write it as 1, and we will not put squared. No? Pero the right thing is squared. Okay, imaginary lang yung 1 mm strip. No? So that's the answer. Find the maximum resultant load in the weld due to eccentric load P. No? Resultant load in weld Newton mm. So it's not resultant load, so it should be resultant stress. No? Okay, so in theory, the resultant force is the farthest point. I mean, the maximum resultant force is the the farthest point from the centroid. So here we can see that our centroid will be at the center. Will be acting here. CG will be acting here. Centroid CG, center of gravity. So the farthest point from center of gravity is not here. Here it will act to this point. To this point. Okay, or you can simply say that the resultant force will be acting here at this point. Okay, but okay, and then resultant shear stress is equals to F times moment times rho over I. Okay, so we should find moment first. So moment is equals to PE. No? So Newton times eccentricity, which is A, which is 200. You will have 72 times 10 to the power of 6 Newton mm. Okay, so solving for I is equals to this here. No? Look at here, the I is equals to BH cubed over 12. That's a general formula for rectangular. No? But here you can say that our base is equals to 1, considering this will be 1 mm. No? And then H is 500 cubed over 12. Tama ba? Yes, that's 500. That's the length of the B. Okay. And then we multiply it by 2 because dalawa yung weld. No? Here and here. Okay. So solving, we have okay 20.833 times 10 to the power of 6. So that's our I. No, that's our I. Let me write it again. 8. So we only have one I because we have only one welded group. No, but if our welded group has X and Y component, we should solve for the individual X and Y component so that we can have a resultant I, or inertia. So that's 20.833 times 10 to the power of 6. So normally this is mm to the power of 4. But we are considering 1 mm strip imaginary, so we have only cube. Okay, so the rho is equals, so our rho is the definition of rho is the distance of the center of gravity, center of gravity to the farthest point of the weld. So this is B over 2, which is 500 over 2, which is equals to 250 mm. Okay, okay, that's 250 mm. Okay, we substitute to this formula. So we have F means stress is equals to 22 times 10 to the power of 6 Newton m over multiplied by 250 mm, okay, over the I, which is 20.833 times 10 to the power of 6. Unit is mm cubed. So cancel. We have F is equals to, I mean stress. No, it's stress. You have 864.01. The unit will be Newton and mm. Okay, this is the answer. So this, I know this is not yet the answer. No, this is not yet the answer because we are asked of the resultant. No, you should be careful about this in the board exam because when you have the answer, no, when you calculate and then you see the answer is letter C, you immediately think that's the answer. No, because the question is the maximum resultant. So the term is resultant load in the weld due to eccentric load P. And then The resultant is basically this lang. Resultant is equals to square root of Fy squared plus F due to torsion, no? Squared. So the resultant is equals to square root of 360 squared plus 864 squared. So resultant is equals to 936. 936 Newton mm. So the answer is really letter D. Okay? Okay, fine. Okay, so for the third question, what is the maximum resultant load in the weld? Load in the weld is 750. What is the required weld thickness? Okay, so force, force is equals to stress V weld times area weld. We have force P, let's say that's P, is equals to 750. F V weld is equals to 93, I think. It's given here. 93. 93. And then the area weld is equals to 0.707. That's this is a design code provision. Okay. So substituting 750 is equals to 93 times 0.707 times thickness of the weld. So you have thickness of the weld is equals to 11.406. Okay, so it's here. Huh? So what will you choose between 12 and 11? So for me, round up. So you have better thickness, greater thickness. You have greater load capacity. So say 12 mm. So that's answer.